Hello, my name is Boris Schubert. I'm fire expert than more than 20 years, and I like to explain you today on the example of cells and fire protection what kind of solution are possible to be sure that the functional integrity is possible. This is a short information basically for the Indian market. The range of the service from the company is functional integrity, fire load isolation, tunnel solutions, physical IT solutions, solutions for batteries, and solutions for smoke. There are separate videos you can later check. Fire protection is a very, very old and very important business. In the old cities, there are the biggest points to protect against enemies and to protect against fire. These 2 points are the biggest points who can destroy the cities. Because of this, we must learn from the fire. This we do, for example, we have a big tunnel disaster in Austria, and there we learn, for example, that a tunnel is something special and we need a little bit higher tunnel regulars to be sure that the systems are working and the people can be evacuated. Fire protection, what does it mean? A big question. We especially do today preventive fire protection, technical fire protection to be sure that important systems are working. This is also in the Indian building regulars and in the National Building Code of India. There's the electrical code and the building code. Both of them speak about fire protection, and especially the electrical code speak about functional integrity to be sure that the safety systems work. Yeah? Safety is the topmost priority. The same you have later with the scope. Fire prevention, life safety under fire conditions is very, very important, and we must be sure that the people can be evacuated and there's no problem with the humans and with the building. Here's also a little bit basic information, integrity, and here's also supply integrity, especially in the National Electrical Code. Important is to be sure that the escape routes are free of everything what can burn, and we must be sure that the people can be evacuated. The best is the self-rescue. If the people can go out of the building by himself, it's the fastest and the best way. We cannot evacuate thousands of people or hundreds of people. The best way is we have a voice alarm system, we have an emergency lamp system, we have a smoke prevention system, everything to be sure that everybody can go out of the building. And then later we only help the people who are, for example, have a problem or cannot go out by himself, and then we evacuate only these people. The important way is to have a self-rescue, and for this self-rescue we need all these systems to be sure that they are working under fire conditions. For this we have normally general public power supply, and then we have a safety power supply. These both systems are absolutely separately, and they must work. The safety emergency system must work during fire conditions. Why we have more and more safety thinking and why we need more fire protection is very easy. We have more and more plastics, and because of this we have more and more smokes, and we have more composition products. We have more acids and we have more dangerous products in the smoke, and because of this we need a higher fire protection. Here you see also for the smoke ventilation we have the standard that they say these ventilators must work during fire conditions, and then we have, for example, some special boxes that protect the electronic to be sure that this electronic is working under fire conditions. You have the same here. You have different kind of system, fire pumps, you have smoke venting system, you have emergency lighting, fire alarm system. All these systems have different kind of minutes. They must work during fire conditions. For this you have 2 possibilities. One possibility is to make rooms, but this room must be big, normally 15 cubics. Or if you don't have a lot of rooms for these systems, not everything together, they must be separately. If there's a fire in such an emergency room, you must be sure that the other emergency systems are working. This is normally in the international standards. They say all the safety systems must work. Yeah? And if, for example, one system is not working, the other safety systems must work. If you have something like emergency lighting, then you have also batteries, and you must be sure that these batteries work under fire conditions. Here we have such a typical solution. If you don't have a room, you use a cabinet, and then in the cabinet you have the batteries and they have the emergency lamp system. Here's, for example, in the underground, we have a lot of emergency systems. Every box is a different emergency system, and we can be sure that this system are working during fire conditions. And then we have a special paint who guarantee, for example, that this metal construction is protected and also is not broken under the fire. This is for IT solutions. We can be sure that, for example, the IT solution in this cabinet is working during fire conditions. This is important if you have, for example, an airport and you have, for example, the flight control. You must be sure that this flight control is working during fire. You cannot put them in a normal IT room because they're normally switched off during fire. But for this cabinet, it's not a problem. The IT system can work during fire conditions. Now, here are modular systems. They are very important for a lot of projects, for the transport and also later for the easy installation. And this is how we do it. This is a fire test, for example, from Germany. We have the ISO curve. The ISO curve is a standard fire curve. This is an international fire. And then we put some power, for example, inside. We make a firebox inside, and then later we test if everything is working under fire conditions. One point is to test an empty system, and then later you think about the temperature. Is it possible that my electronic is working inside or not? Another point is, this is later from outside. It's made same like an onion. It's going broken layer by layer, but inside everything is fine. And then this is another test. This is a type test, we say. There's, for example, the safety system inside. And then we put this in the testing room, function cable, electronic inside. We connect them to be sure that the data transfer is possible. 1000 degrees after 90 minutes. And then later we see the electronic is okay, is fine. The system is working during the fire. And then we can say, we can guarantee that the system is working during fire conditions. Tunnel requirements are a little bit special because you have a capsule room, you have not so many escape routes, and you have the big problem that in tunnels you have not a normal light, and the evacuation is much more difficult. Because of this, you have also in metro station in the Indian regulars some specials, and you have, for example, also here a little bit higher standards to be sure, for example, for the tunnel ventilation, that everybody can be evacuated. This is, for example, for sprinkler system. Here's a sprinkler system in the box. They don't use a room, they use a small box, and this box is much more easier to install, and it's a bigger protection because here you must not open the wall. You have no problem of some gaps or some water. You have absolutely dry tunnel because the system is from the drilling machine exactly installed in the tunnel. We use the systems in a lot of airports, in a lot of medical facilities, in a lot of industrial facilities to guarantee that all the important electronics are working. The same is with financial institutes. They also use the system to be sure that everybody can be evacuated, and sometimes, for example, to be sure that the stock exchange get enough energy to work under fire conditions. We make a lot of seminars about this. If you have questions, write an email. We have local partners everywhere. Thank you a lot.